Welcome back again. Let me start a new series of videos on work energy power for your JEE main and NEET and also for your school board examination. And as far as engineering mechanics is concerned for BTech students, I will be soon uploading new videos. So let us begin. Work done by a constant force. So all of you are aware of what is a force is represented by. I will solve few numericals also in the series of videos, important numericals. All of you are aware of a force represented by a symbol F. The unit is either a Newton or dyne, and a Newton is a very small force, and you know how displacement is expressed in meter. So what is work done in physics is explained like this. So W is equal to, symbol for work is equal to F dot S. F is a vector quantity, S is a vector quantity, and as you know, dot product is a scalar quantity, the magnitude of the first one and the magnitude of the second one, and theta is the angle between the force vector F and the displacement vector S. And now now if you look at the three diagrams here, here is an object is acted upon by a force F, and this is your horizontal. Now, and the displacement, if you consider the front end, and the front end is here, so the object has been displaced from this position to this position, let it be S. So in this case, your work done will be, this angle is theta, which is less than 90, that is acute. So cos theta, if the value of theta is less than 90, cos theta will be positive, so the work done will be positive. Now, so as you know, the rectangular components of a vector in a plane, if you look at this F, if you resolve into rectangular components, your one component will be this, and your other component will be from here to here. So if you take and all of you are aware of how to find the cos, and this will be equal to your F times cos theta, and this will be your F times sin theta. Now this object is moving towards right due to F cos theta, and this is the displacement, and this F cos theta, they are in the same direction. This is the same F, this is the same theta as this. So it's a product of the force and the component of the force F cos theta times the displacement. Now then you might be wondering what happens to this F sin theta. Its weight is vertically downward, and since F sin theta is not sufficient enough to move it to this side, therefore there is no work done due to F sin theta, because the displacement is to this side, F cos theta is to this side, so the angle between them is 90. So if you want to find out what is the work done due to F sin theta, the angle between F sin theta and displacement vector is 90, so put cos 90 here, so work done is 0. So the only work done is due to this component of the force F. So since this F cos theta and S are in the same direction, so the work done and theta is less than 90, so the work done is positive. Now in this case, what happens? What this F cos theta will do? Since this is a force, and any force is associated with acceleration, that is A is equal to F over m. So, and you know the meaning of acceleration? If acceleration is equal to 2 meter per second square, which you can well write it like this, 2 meter per second per second. If you look at, this is the velocity part, this is the time part, second means 1 second. The meaning is, the speed increases by 2 meter per second in each second. In every second, the velocity increases. The speed increases by 2 meter per second. So in this situation, theta is less than 90, cos of theta is positive, so the work done is positive. And the force is trying to increase the speed of the body. It's trying to increase the speed of the body. Now let us come back to the second diagram. The same force M, F, I have represented it here. Now I have represented it here. Now the displacement is to this side, let it be S, and the angle between this F and this S is 90 degree. So if you put cos 90 here, cos of 90 is 0. 0 times S times F is equal to 0. So in this case, work done is equal to 0. Then you might ask, if the force is to this side, how this is moving to this side? So let us assume this is already moving to this side with a constant velocity. Means there is no change, there is no increase in the speed. Therefore, there is no acceleration. Therefore, there is no acceleration. Now, therefore, there is no force. Since A, as you have studied in your school days, final velocity minus initial velocity over time, if this is moving to this side with constant velocity, the value of initial and final are same. So this minus this is 0, 0 over this thing is 0, so acceleration is 0. So to this side there is no force, it is just moving, right? And in that case you are applying a force to this side, and this body is not able to move up due to this force. So there is no displacement in this direction. So, but the displacement is to this side, and this F and this displacement, they are perpendicular to each other. So if you apply theta is equal to 90 degree, work done is equal to 0. So in this case, work done is 0. And in this case, W is equal to positive. Let me use a different pen. Okay. In this case, W is equal to positive, and in this case W is equal to 0 because theta is 90. Here, due to this F, one of the component is F cos theta, and the F cos theta is to right side. And since this is a force, so this body will have an acceleration, means its velocity is trying to increase. So due to, if the F is making an acute angle, the speed of the body tends to increase. Now then, coming back to the third one, I will do few numericals also. Now suppose the same force, it is the same force. Now if you look at this angle is obtuse, greater than 90. So one component of this F will be to this side and the other will be to this side. If this is theta, this will be 180 minus theta. So this will be your F times cos of 180 minus theta. So since it was already moving to this side at constant speed, so the displacement is from this point to this point, let it be S. And if you use the expression for W is equal to F dot S, that is Fs cos theta. So theta is greater than 90 degree. Therefore, cos of an angle greater than 90 is equal to negative. So this value becomes negative. So the work done is negative. So your W in this situation is negative. Now what this force is doing? This was already moving to this side at constant speed, means there was no acceleration. So this force, which is opposite to that, this will try to reduce the speed of this body, right? So work done is negative, the speed of the body is reduced. Now you might be wondering what happens, what this one is doing. This will be your F of sine 180 minus theta. And since there is no displacement in this direction, so this is not doing any work. The displacement is to this side. The angle between this displacement and this force, which is a component of this F, that is F of sine 180 minus theta, angle between them 90. Angle between this force and this displacement is 90. So cos 90 is 0, so work done is equal to 0. Now I'll switch on to numericals now. So what we just learned, W is equal to F dot S, the dot product of first magnitude of the first, magnitude of the second, cosine of the angle theta. And if theta is less than 90, as in this case, work done is positive. And the component of this force trying to increase the speed. And in the second case, if theta is 90, angle between the force and the displacement is 90, work done is 0. So there is no change in the speed. And in this case, if theta is equal to obtuse, greater than 90, then cos value is negative, work done is negative. And the component of this force, that is this one, which is against the motion of this body, is trying to decrease its speed. So work done is negative and the speed is being decreased in this case. Now let me go to the next page to solve a numerical, then solve one more. So let me begin with the first numerical. A particle of mass 200 kg. This mass is 200 kilograms, is displaced through a horizontal distance 10 meter. From this front end to this front end, the displacement is given as 100 meter. This is 200 kg. By pulling it by a chain inclined at an angle of 60 degree to the horizontal. This is being pulled to this side by a force of given as 100 Newton. And this force makes an angle of 60 degree. That is what it is given in the question. And since W is equal to F dot S, magnitude of this, and cosine of the angle between the force vector and the displacement vector. Now, this force and this displacement, there is angle 60. So if you just put the values, so your work done is equal to F is cos of 60. F is given as 100 Newton. Displacement is given as also 100 Newton. Displacement is given as 10 meter. Displacement is given as 10 meter. So I'll make a correction here. Displacement is given as 10. And cos of 60, that is equal to 1 by 2. This cancels. So 500. So work done is equal to 500. And since this was given in Newton and the displacement in meter, so this many joules of work is done. This many joules of work is done. You can look at it this way. If you consider the component of this in the direction of displacement, then the component of this force to this side will be F of cos 60, and this displacement in the same direction as F of cos 60. So you can interpret this way: work done is equal to the force, that is F cos 60 times the displacement, and the angle between this force and this displacement is a 0. So put it cos of 0 here. Cos 0 is 1. So that is same thing as Fs cos 60. So F is given as 100 Newton and displacement as 10 meter. Cos 60 is 1 over 2. This cancels. So 500 joules of work is done. Now you might be wondering, then what about the component of this force, that is this one, and this one will be your F of sin 60, and this body, due to F of sin 60, is not able to move upward, means its weight is more than this or just equal to this. Therefore, this is neither moving upward nor downward, but this force is acting and the displacement is to this side. So angle between F sin 60 and this displacement, angle between F sin 60 and the displacement, angle between them is 90. So due to this, no work is done. How you have to write that? This force, F of sin 60, displacement is to this side, that is 10. Between this force and this displacement, between this force and this displacement, angle is 90. So put it here as cos of 90, 0. So 0 times this is equal to 0. So due to F sin 60, there is no work done. Fine. Now what else you can say? The work done is positive, and since this is a net force on this mass, there will be an acceleration to this side, this side. And how much will be that acceleration? Since A is equal to F over m, this F cost 60. F is given as 100 Newton. Cos 60 is 1 over 2 over its mass, that is 200 kilograms. So this cancels with this. So 50 over 200, and that is equal to 5 over 20, that is equal to 1 over 4 meter per second square. So means this object, while being acted upon by a force 100 Newton, making angle 60 degree with the horizontal, is moving to this side with this acceleration. Means its velocity increases in every second by 1/4 meter per second, right? So you can further extend this problem. You can find out what will be its velocity after 5 seconds, what will be its momentum, what will be its kinetic energy, what distance it will cover. All those things you can find out since the acceleration is known. How can you do so? Since acceleration is 1/4, so you can use this. If the body had started from rest, you can use v is equal to u plus at to find its velocity. He started from rest. Acceleration is equal to 1 by 4. Suppose it is given as at t is equal to 4 seconds. What will be the velocity? So put t is equal to 4. So that is equal to 1 meter per second. Then you might ask what distance it will cover in 40 seconds. In 40 seconds, starting from rest. Then you can use S is equal to ut plus half a t square. Since it started from rest, u is equal to 0, so this time becomes 0. Half is, we just found it as 1 by 4. A 1 by 4 meter per second square. So in 40 seconds, and 40, put 40 here, 40 here, because it is a t square term. So 8, 2 4s are 8, 8 5s are 40. So 5 into 40, that is equal to 200 meter. You can also find out its momentum, since you know symbol for momentum is P, is mass times velocity. Now, if you want to find the momentum at a t is equal to 4 seconds, suppose, and at t is equal to 4 seconds, we have found out the velocity as 1 meter per second. So mass is given. Mass is given as 200 kg. Mass is given as 200 kg. So you can put 200 here. Velocity after 4 seconds, we calculated as 1. So put it 1. So that is equal to 200. And the unit of momentum will be mass into velocity. That is kilogram meter per second. So that is, you can also find kinetic energy. You can also find kinetic energy is equal to half m v square. Since it started from rest, half is constant, m is constant. Then you have to say kinetic energy at what time? Let's say t at t is equal to 2 seconds. Then for t is equal to 2 seconds, you have to first find the velocity. Since the acceleration is constant, you can use v is equal to u plus at. Starting from rest, this is 0. A we found out 1 by 4. At t is equal to 2 seconds, put 2 here, so is equal to half meter per second. So what will be kinetic energy? So your kinetic energy will be half mv square. M is given as 200 kg. M is given as 200 kg. So put m is equal to 200. At the end of 2 seconds, the velocity is equal to 1 by 2 square of that. That is equal to 1 by 4. So cancels with this 50. So 50 over 2, that is equal to 25. And the unit of energy, kinetic energy is joule. So this many joules, joules. Now let me do one more numerical, and then I will, in the next videos, I will gradually move on to complicated numericals, and I will explain you how to use work energy theorem also. Let us do another numerical. This one is important for your, not for your school examination, rather you can say for NEET examination or for JEE main, not for JEE advanced. Now let us look at the problem. A particle moves from a point R1 is equal to 2i cap plus 3j cap meter to another point R2 is equal to 3i cap minus 2j cap meter, during while it is moving from this position to this position, a constant force F is equal to is equal to 5 I cap minus 2 j cap. Newton is acting on it. Find the work done by the force on the particle during the displacement. Now, if you look at this force, this is a constant force. So you can use this. Now, let me first explain you what is the meaning of this. R1 is 2I cap plus 3j cap and R2 is equal to 3I cap minus 2j cap. Now, I have shown it in a... There is no need to solve this problem using this graph. You can straight away do that. But to explain it better, I have drawn a coordinate system xy. This is your R1. Means if you drop a perpendicular from here on x-axis, this part will be 2 units. 2 units along x-axis. From here, if you drop a perpendicular from here to here, is 3 units along a y-axis. Means initially the body was here, having coordinates 2, 3. 2 units along x-axis, 2 I cap, because I cap is a unit vector along x-axis. 3 units along y-axis, so 3 j cap. J cap is a unit vector along y-axis. So initially the body was here. Now it moves to a position given by R2 is equal to 3 I cap minus 2 j cap. So R2 I have also shown it here. From here, if you drop a perpendicular on x-axis from here to here, from this point to this point will be 3 units. Since it is along positive x-axis, so 3 I cap. Then from here, if you drop a perpendicular on y-axis, from here to here is along negative x-axis, and the length is from here to here is 2 units. Minus 2 j cap means it is along negative y-axis, where j cap is a unit vector. Now, initially the body was here, now it is here. So the displacement is, so this is the displacement. So this is your displacement. So this is your displacement from here to here. And that displacement will be how much? If you have studied parallelogram of law of vector addition, if you consider this as a vector, this as a vector, then the sum of the two vectors was given by the sum of the two vectors was given by this diagonal. This is your R1 vector plus R2 vector. And this is your R2 minus R1. And this displacement is nothing but R2 minus R1. Is R2 minus R1. Means final position minus initial position. How this is R2 minus R1? Let me explain it, then come back to the numerical. R2 minus R1 can be written as R2 plus of minus R1. Now, R2 plus of minus R1 means the resultant of R2 with minus of R1. If there is a plus sign between two vectors, it means the resultant. Now, how this is the displacement, that is same thing as R2 minus R1. Let me explain by the saying, if this is R1, your minus R1 will be just opposite to that. I have to take the same length. Okay, just I have to take the same length from here to here, 5.5 from here to here. So it will extend up to this side. Now this vector is your minus of R1. Now, so the resultant of R2 with minus of R1, if you construct a parallelogram, it will be it will be this one, from here to here, this one. That is same thing as this. So this is same thing as this. So your displacement is when it is moving from the position R1 to R2, the displacement is R2 minus R1. The displacement, your displacement vector is R2 minus R1. And how much will be that? That is equal to 3i cap minus 2j cap minus of R1 minus of 2i cap plus 3j cap, that is equal to 3i cap minus 2j cap minus 2i cap minus 3j cap. So this becomes 0. So we have minus 2, sorry, I made a mistake here. 3i cap minus 2i cap is equal to I cap minus 2j cap minus 3j cap is equal to minus 5j cap. This is your displacement. So your work done will be, F dot, will be your F dot. So your work done will be F dot S, and your F is given as 5i cap minus 2j cap, 5i cap minus 2j cap. The displacement we just found out as I cap minus 5j cap, and in dot product 5 pi dot I dot I is 1, 5 into 1 5, 5 pi dot of minus 5j, I dot j is 0, so 5 pi dot 5j is 0. Then minus 2j dot I, j dot I is 0, so the contribution of minus 2j dot I is 0. Then minus 2j dot minus 5j, j dot j is 1, so minus, so this is equal to 10, so answer is equal to your 15 joule. Work done is positive. So 15 joules of work is done. So when a body moves from this position to this position, how you have to find the displacement, I explained you vectorially. There was no need to draw this diagram. You could have straightway write it as F dot R2 minus R1, and straightway you could have found out, right? So that is all about. Then there was a mistake here. 3i, this is j, this will not cancel. 3i cap minus 2i cap, that is equal to I cap, minus 2j cap minus 3j cap is minus 5j cap. This is the displacement. Means going from this point to this point, this value is equal to I cap minus 5j cap. If you want to say what is the value of this displacement, as you know how to find the magnitude of a vector, in front of this the number is 1, in front of this number is 5. So the value of the displacement will be square of 1 plus square of 5, square root of that. We are not interested in that. We are just interested in finding the work done. So this is how it is done. Then I will move on to complicated problems, and I will explain you work energy theorem and how to use it efficiently and quickly to solve numerical problems in physics. And maybe I will be uploading about 30-40 videos on work energy power, how to use work energy theorem. Even if there is friction is present, external force is present, how to solve numericals quickly. I will explain in the oncoming videos. Thank you for the time being. Thank you.